Great.
Um, Good day, morning, evening, afternoon, wherever it is in the world that you are, to this month's EMEA partner webinar. Today, we're going to be giving everyone an introduction to Docker containers and CI CD. My name is Mark Swanson. I'm the IT storyteller for the NetApp on NetApp team, and we are joined with Jonathan Fair, who will be taking you through all things containers and CI CD. So, Jonathan, I will hand it off to you.
Thanks a lot, Mark. Everyone, my name is Jonathan Fair. I'm a DevOps engineer at NetApp. And again, this is our Docker containers and CI CD introduction webinar. This is an introductory webinar. So for those of you who have little to no experience with Docker and the advantages of build and release automation, this is a part two of a two-part series, the first of which was presented by David Fox, who covered Kubernetes basics. I will open it up for Q&A at the end. So if you have any questions about a slide, just mention it and I'll be happy to go back to it. So what is a Docker container? I think the easiest way I can explain it is it's simply an image that is generated by a set of instructions called a Docker file. I know this is very, very basic. A lot of you probably have some experience with this already, but I just kind of wanted to start very basic, introductory, and then kind of work my way through. So I'll show an example of a Docker file in a later slide. Once the image is built, it can be uploaded to a Docker registry like Docker Hub. The host, whether that be a VM or a Kubernetes node, can then download that image and run it pretty quickly and easily. Typically, a Docker container will only run a single process. So if your application requires 10 services or 10 microservices, then you'll generally have 10 Docker images. For example, one image to run Nginx, another image to run, let's say, a logging tool like a Splunk forwarder, and another image for your API instance, and another image for any other services that you have. You'll also may break down your let's say your API into multiple microservices, into different modules. So you'll have different Docker images for that. When you download the image and run it, we call the running instance a Docker container. You might think, well, what's the difference or benefits of from a Docker image and a virtual machine image? The primary benefit is that it's easily modified. If you want to remove a package, you simply edit the Docker file and remove that line that performs the apt get install whatever package. Then you just rebuild the image and you have a fresh image that doesn't have any traces of that package. You can then just distribute it across your VMs or your Kubernetes nodes, and it'll be identical across all of the instances and containers that are running. Another key benefit is the ability to distribute and deploy it quickly and easily. Due to the size of the image, I can download and spin up an Ubuntu Docker container on my local machine within 5 seconds. I'm using Ubuntu here as an example, just due to its familiarity. However, most Docker images are based off of Alpine or Debian. There are many vendors that provide pre-built Docker images that's readily available. So instead of you downloading an OS image like Alpine or Debian, and then it's doing an apt-get install Nginx within the image or within the Docker file, you can simply just pull down the image provided by image provided by Nginx, and it'll have all of that pre-installed, pre-configured. You just run it. So now I want to start digging into what DevOps and CI CD is, and then I'll come back to Docker a little later. So if you look at a traditional application development and release model, you'll typically see two teams. And here's just an example here. You'll have a development team who's responsible for developing the application code and determining the required packages needed to run the application. They'll then schedule something like a monthly release where they'll work closely with the operations team to deploy their code, update the server, install or update any required packages. Sometimes the operation team may have some level of automation, such as Ansible, Puppet, or Chef, to make those changes and configurations across the VM environments. Now, the DevOps model is more or less just a mindset. The developers have some experience with operations, and the operations members have some experience with development. These members are within the same team and work closely to develop, build, and then deploy the application. And the best way to do this is with CI CD automation. So let's now dive into CI CD. So CI refers to the continuous integration. The CI process is completely automated. When a developer commits any application code to their repo, you can have it automatically kick off this CI process. So the CI may contain many other steps not listed here, but these are the typical required steps you'd see in a basic CI pipeline. The CD may be referring to either continuous delivery or continuous deployment. The term continuous delivery is used when there is manual intervention needed to perform anything, any kind of testing needed, UAT, and then continue the pipeline before, in order for it to deploy to production. The term continuous deployment is used when there is automated end-to-end testing and predefined rules that determines if it will deploy to production. This is ideal, as developers can then just push through changes as quickly as possible without any manual intervention. You can also have automatic rollback. So if it does deploy to production and you have some monitoring in place that will take a look at logs and performance tests, you can have it automatically roll back as well. That's part of your continuous deployment. So if we take a look at a traditional non-CI CD example, a user would develop some code, push it to a Git repository, then a user will copy over the application code or binaries and install any required packages onto the VMs, as well as make any manual configuration changes, package changes on the VMs. A user might even use something like Ansible to automate the distribution of code and perform the installation of packages on the VM. Some would say that this is a form of CI CD. However, this typically does not include any type of automated testing of the application and wouldn't really qualify as CI CD. Although you can use Ansible as part of your CI CD workflow. When you get Docker involved, this makes the build and deployment much easier, since the user just needs to run a few commands to build the image, push and pull the image down to your host, and run the application on multiple VMs. And you'll know that each instance will be 100% identical. You don't have to worry about downgrade Nginx or upgrading Nginx or whatever it may be that you need to make the changes on the VM. You simply just bake it into an image, deploy that image. You can deploy to VMs. Docker can run on VMs. However, it's preferred to deploy onto Kubernetes, and that's typically when we get CI and CD involved. The user intervention is minimal to non-existent. The developer just pushes the code, and it'll build the application and bake it into an image. And then the CDU will deploy that image to your Kubernetes environments. One benefit of this is it reduces the number of users that are required to join, let's say, a monthly after-hours call for an application release. Even better is that if a developer needs to fix a simple bug, they could code it up, commit the fix to their repo, and then have it live in production in less than an hour. So this allows for dozens of micro releases per day from multiple developers, as opposed to one or two massive releases per month. So the flexibility and the ability to push out changes as quick as possible is a real huge benefit here. With Docker and CD, rollbacks, as I mentioned, can be simplified as well. If that developer realizes that the bug fix caused some undesired side effects, that small feature can be rolled back instantly. The tech giants are pushing out hundreds and even thousands of production releases to their key product every day on a daily basis. So they may have their key product will have multiple services. They may have some developers working on this service, some working on this, and they're able to just crank out those releases many times a day. Okay, now for my favorite part. So we finally take a look at some real examples instead of a bunch of lame icons. So I'm going to be building a very simple hello world Docker image here. My Docker file has a set of instructions, which I'll be using Debian as the base image here. So you can see here, it will install Nginx, inject my custom Nginx config, inject my source folder, and then it tells Docker what process to start when the container comes up. If I want to just update my OS, all I have to do is I just change this 10 to an 11, rebuild the image, and I've updated my image to the latest to a newer version of Debian. Or we could simply just use the official Nginx image as our base image, which removes the need for us to maintain the Nginx installation portion. So the Nginx base image also includes the startup process configuration. So we don't need to mention that here either. And of course, your Docker file is going to look a lot more complex than this. Ideally, you want to configure it to run as non-root for security reasons. Most base images run as root by default. So if you you open up a shell into the running container, you'll see that the Nginx process is actually running as root. So in your Docker file, you would make whatever permission changes you would need to tweak it and configure it so that it's not running as root. Once we're finished defining the set of instructions, we run a command to build the image. I'm just naming our image as my app and setting the tag or version as 1.0. And then another command here to bring up the container from our new image. Downloading the base image should take around 5 seconds and only needs to be done once. So this Nginx base image, it'll first pull that down, take about 5 seconds. Once it's cached on your system, it doesn't need to pull it down anymore. The next time you do a Docker build, it'll just build whatever you're wanting to bake into the image, any changes you've made. The build takes around 2 seconds, and then bringing up the container will take less than a second. The same concept of updating it applies here as well. If you want to use a newer version of Nginx, I simply just update the version here, rerun the build command, and it builds a new image using a newer version of Nginx. So maintaining packages and resolving vulnerabilities is much easier with Docker. So once we have our Docker image, let's take a look at how we can deploy that to Kubernetes. So the first step is to upload or aka push it to a registry. We then define our Kubernetes deployment manifest, which will tell Kubernetes what our application should look like. And you'll have several manifest files for deployments, ingress, traffic. So here's a basic manifest that shows we want to deploy 3 replicas of our single of a single container, which will result in 3 instances of our custom image running. As I mentioned, you can define create additional manifests that'll define ingress traffic and load balancing between those 3 containers. And then if one of the containers crashes or hangs, Kubernetes can automatically restart that container to prevent any outage or downtime. So you have resiliency there. Then with a single command, we can apply our manifest to Kubernetes, and Kubernetes will create whatever we've defined here. If I wanted to, let's say, change it to 5 replicas, I just have to update this manifest to show 5 and then rerun this apply command, and Kubernetes will instantly spin up 2 more containers. Now that we've done those steps manually, here's an example of an Azure DevOps pipeline definition. You can use things like there's GitHub Actions. There's other third-party vendors out there that have CI CD tools that you can build your own pipeline. But this is generally what it looks like. This technically doesn't qualify as a CI CD pipeline since it's missing some key steps such as automated testing. But hopefully it will give you an idea. So when I commit any changes to my Nginx config, HTML files, or Kubernetes manifest, it will automatically kick off this pipeline. And the first task here, you see that the pipeline will build the image based on the Docker file we created earlier, and then it will push that image to our self-hosted Docker registry. In the second task, the pipeline will apply our Kubernetes manifest to the Kubernetes cluster. This means that any changes I make to my code, I can see it live running in Kubernetes in my development environment in just over 3 minutes. So it makes development and pushing it out extremely easy. Again, I can also run it on my local machine as well. So if I want to make some code changes, run the Docker container on my local machine, whether that's Windows, Mac, Linux, I can run on my local machine, the Docker containers on my local machine. Then once everything looks good, I commit the code and see it live in Kubernetes. Here's just a few benefits that I came up with using Docker and CI CD. I think I covered most of these except for maybe the last two. As for the compute overhead, if you'll remember when I said that an image typically runs only a single process, that's a single process. For example, Nginx may spin up some sub processes. The top level Nginx process may have some threads or some extra processes, sub processes that's running. So if you run PS command, you'll see maybe 5 processes for that Nginx instance, but you'll have that one top level Nginx process. So if you get to a shell prompt within the container, again, PS will just show you that single top level process. If you had Nginx running on, say, a VM and you run the PS command, you'll see over 100 processes running for the underlying OS, which consumes a lot of CPU and memory. So with Docker running in Kubernetes on a Kubernetes node or on a VM, instead of having 3 VMs for your 3 application services, which it's going to be consisting of, let's say, 303 processes, you can have a single Kubernetes node or VM running those 3 services in containers, reducing the number of VMs required to run your application, which now consists of only 103 processes. So security is another deep topic. I can talk about it if there are some of the security benefits, if there's any interest here. I felt that it was at least important enough for me to mention it here. So that is the end of my presentation. Go ahead and open it up for Q&A. Mark?
Yeah, initial question. Like sometimes my Docker container or it's deleted and all the data seems lost.
Yeah, that's a good question. So a Docker image will contain whatever you baked into it in the Docker file. When you bring up a container, that container.
Hello?
Are you able to hear me?
Yeah, I got you.
Okay, great. Sorry about that. Yeah, the container will only contain the packages and configurations that you have defined in your Docker file. Now, let's say your application is creating some temp files or creating, some files or modifying some files within the host OS. It downloaded something from, downloaded BrowseCap or something. That'll be stored within the container and it will be available inside the running container. So your application can consume any resources that it generated or downloaded. However, when that container is killed off, anything that was generated in that container is also wiped away. So when you bring up a new container, it will be using the image to generate that container. So if you want any persistent data, let's say if you need a directory where your application can, let's say, store logs, for example, and you want those logs to be persistent across container deletions, you can create on your local machine, you can create what's called a volume or a local mount. And what that will do is it'll mount a volume on your local machine to the Docker container. And that way, when it's writing files, it's not really writing the files inside the container. It's writing those files to your local machine. However, the container, it thinks it's writing to var log, but it's really writing to your local machine. In Kubernetes, you'll use PVCs, persistent volume claims. And again, you'll create a Kubernetes manifest that will have that PVC defined. And then again, your application will be writing its log files or any generated files or downloaded files to that PVC. And that way, when the pod or container is restarted, it'll mount the new container that comes up will mount that PVC, and any data or logs or any information will be available.
Okay, that makes sense. How do I assess my Docker container?
Okay, I think you said your audio is breaking out a little bit, but I think you said SSH. How do I SSH in my container? So you generally wouldn't have SSH abilities within the container because, as I mentioned, you're only going to have one process. So for that Nginx container that's running, if you PS, you're not going to have any SSH service running in the background. As a matter of fact, SSH won't even be installed. That's one way that these images are so light. You won't have SSH running in the background. So what you'll do is you can do a Docker exec, and you can actually exec into the container. In order to run the exec, typically you will have to be on that local machine, so the host. So if you're running your container on a VM, you'll SSH into the VM, and then you can Docker exec inside the container. If you're running in Kubernetes, you can run a kubectl exec remotely, and it'll allow you to exec or open up a shell prompt within the container. You typically won't SSH, if you will, into your container because it's immutable. You're not going to go in and change a configuration file on the fly and then restart services. Typically, what you would do is on your local machine, you would have your Docker file. You would make the configuration change on your local machine. You'll test it, restart services, if you will, which is simply just building the new image and running a container on your local machine. Test it, make sure it works, and then you'll again commit your code to the repo, and it will just push the new image and deploy the new image into your environment with the new configuration changes. So you're not going to SSH, make configuration change, restart services, and then and see if it works. You're just going to do all the testing on your local machine, and any configuration changes you make will get deployed automatically to production. This makes sure that there's a paper trail, so users can see who's making what changes. If you just SSH to a VM, make a config change, nobody can tell who's doing that. So it leaves a paper trail and a way to revert it very quickly if needed. As far as logs, you're not going to SSH into a container and tail the logs. Generally, you're going to have some kind of logging service or system, such as Splunk, that has the logs ingested on the fly, and then you'll do all of your tailing, if you will, in that logging service.
Gotcha. I guess we're all familiar with DevOps and all things around that, but what's like DevSecops? It's more of a newer thing.
Yeah, DevSecops. So when you think of DevOps, of course, it's developers plus operations. DevSecops is development plus security plus operations. So you would also throw in some security in there. So when your CI CD pipeline is running, your CI, part of your CI, you are going to be maybe scanning the actual code, for any bad practices or vulnerabilities. Then you'll build the image. Once the image is built, you may then perform some security scans, have some tools that will perform security scans against the image to scan all the packages installed on it. So it'll make sure that the Nginx package that's installed doesn't have any, you're not running a 5-year-old version that's going to have vulnerabilities. So you'll have that baked into it as well. And then you'll have go, no go. So maybe you'll allow it to deploy to development environment. You're in Kubernetes, your development environment, if there's security vulnerabilities, but maybe you don't want it to deploy to stage or prod with any outstanding critical vulnerabilities. So as part of DevSecops, you have that security in mind. And again, DevOps is just a mindset. So DevSecops is kind of that same mindset where you make sure you integrate security in with your practices. Good question.
Gotcha. Recently, I've seen DockerCompose thrown around a lot. Can you kind of go into the end of what exactly that is?
Yeah, so DockerCompose is used a lot on if you're deploying this on either, let's say, a local machine or a VM. I see this almost everywhere that's non-Kubernetes. So if you remember that Kubernetes manifest that had that deployment YAML, which defined what our application should look like, that's specific to Kubernetes. If you want to deploy it onto your local machine or on a VM, that Kubernetes manifest, if you're not running Kubernetes on that VM, that Kubernetes manifest isn't going to do anything. So there's a DockerCompose, it'll actually be a file called dockercompose.yaml. It's a file where you, just like that Kubernetes manifest, you'll define everything that your application should look like, any local volumes, any ports, any environment variables, the images. You can have multiple services defined in that DockerCompose file. And that way, with a single command, DockerCompose up, it will bring up all the services at one time with all of the configurations defined in that DockerCompose file. So you don't have to remember a long command like docker run /it/ or you wouldn't use IT, but docker run /-v, 80:80 and then 443:443 and then list your volumes. You don't have to remember this long docker run command. You just put all of it in this DockerCompose file and then just run a DockerCompose up, and it will bring up your instance. So if you're running on a local machine or on a VM, DockerCompose is my preferred method of managing the containers.
Right. Constantly running into size issues, storage issues. How do you make a Docker image smaller? Easier to work with? Yeah,
so I've actually worked with several teams that they're asking me why their builds are taking a long time, and I'll take a look at it, and they've got a 2 gig Docker image or a 3 gig Docker image. There's a lot of best practices when it comes to building a Docker image. Things like managing your layers. So when in the commands where you saw that I was, injecting the custom Nginx config and then injecting the source, let's say you needed to download some, as part of your build, you need to download some third-party Git repository or download some package. And then you just, like an RPM, you want to download an RPM and you want to install the RPM. If you have one run command that downloads the package and then another run command that installs the package, you now have 2 layers. Each layer, let's say that package that you downloaded was, let's say 100 megabytes. That first run command is going to download a 100 megabyte file. And then when you run the second command, the second run command, it's going to then unzip and install whatever was in that RPM, right? And pull any dependencies down. So you're going to have another 100 megabytes plus, because it's all extracted, and other dependencies. Now you're going to have 250 megabytes. What you're better off doing is having a single run command and chaining those commands into one. So what you would do is, in that single run command, you would pull down the package, the RPM package. You would then install the RPM, and then you would remove that RPM package. That we only have the 105 megabytes within that single layer. even if you had one run command that downloads, I see a lot of people do this. If you have one run command that downloads a package, then let's say you have another run command that installs the ARP package, and then a third run command that then deletes that RPM. That third run command that deleted the package does absolutely nothing. It does not free up any space because that first run command added that layer, that 100 megabyte layer to the image. Once a layer is part of an image, it cannot be removed. So you can remove all the files you want, but that will not reduce your image, by 100 megabytes. You need to, if you're going to remove a file, it needs to be within the same run command that the package was downloaded. Another common thing that I see is file permissions. So I'll see sometimes somebody will copy files into their image, or maybe download files to their image, and they'll do something like a chmod or a chown, let's say Nginx on the entire folder. Let's say you download the folder, it's running as root, it downloads the folder, all the files are owned by root, and they want to change it so that they change the permissions to their custom user, and then they'll chown it. The problem with doing that is, let's say you inject or you download that package in one run command. Okay, so you have 100 megabytes worth of files that are owned by root, and then in a second run command, you will have you chown it. Now you have one layer that contains all of the files, 100 megabytes worth of files that are owned by root, and another layer that now has the 100 megabytes worth of files owned by your user. You now have 200 megabytes, within those two layers, 200 megabytes in your Docker image. If you simply combine those into a single run command, so you download it and then chain on, do an and or a semicolon, and chown the files within the same run command, you will only have a one layer that only has the remaining files that are all chowned by your custom user. Other things like multi-stage builds. So let's say you need to compile something. You don't want to install, make and GCC and all this stuff into your image, even if you're going to remove it later, because like I said, if you install those in one layer and then you build compile your whatever you need to compile, and then you do an apt-get remove or whatever, you're still going to have that layer that has all of those packages in there. So what you would typically do is you'll have one Docker image, or not Docker image, but within your Docker file, you'll have multi-stage builds. So you'll have it compile it, and that generates one image. And then your final image is then just going to pull in the file, the binary that was the resulting binary that was compiled. So there's a lot of things you can do to reduce the size. As far as speed and performance of your builds, just keep in mind, if you have, let's say you have 15 run commands, if you make a change to, let's say, a run command, or you make a change to an Nginx config, and that Nginx config is injected in the middle of your Docker file, that Docker file will need to rebuild anything from that Nginx config and down. So if you have something like, inject Nginx config and then inject your source code, if you modify the Nginx config, the build is going to have to re-inject that Nginx config, then re-inject your source code. And then if you had, let's say after that, you had an apt-get install and then some package, Nginx, it's going to have to download and reinstall Nginx or whatever your package is every single time. You're better off having your apt-get installs at the top, and then maybe your source code and configurations towards the bottom. That way, if you make a change to your Nginx config, it's only rerunning that last step, that last run command or copy command. There's a lot of other things you can do to make the image size smaller. A really good tool that I use is called Dive. It's independently maintained, independent tool, but Dive is a really good tool. Dive actually there's actually a Docker image for Dive. So you don't even have to install Dive on your local machine. You can run Dive within a container to inspect other Docker images. So it's a really useful tool. It shows you layer by layer what's happening. It's a very, very useful tool. It helps you kind of wrap your head around what's happening within your image. So good question.
Okay. We have a question from the chat. Share the list of best practices for both Docker's with performance optimization steps.
Sorry, I didn't catch that. Something about performance steps?
Yeah, can you share the list of best practices, Docker Kubernetes with best performance optimization steps?
For running Docker in Kubernetes?
Yes.
I don't have any best practices for performance running Kubernetes. Okay, I see here in the okay. Yeah, sorry, I don't have a best answer for that.
Okay. I guess do operation teams like need to become developers now? Is that where a trend is going?
Not necessarily. So when I mentioned that you'll have developers that have some operations knowledge and some operations members will have development experience. Generally, you'll have it's very, very difficult to find a developer, a full-time developer that's also a full-time operations. So generally, your team is going to consist of some members that have some development experience and some operations experience, and you want as much overlap as you can find. So I look at the DevOps. I always kind of picture in my head, you have the dev and you have the ops. So I'm more of probably a VOPS guy, maybe an EVO guy. So those three letters in the middle, that's kind of where I fit in. I'm not an expert in development, and I'm not an expert in operations. I have worked a little bit in each field, but I wouldn't call myself an expert in either. So you may have some members on your teams that's the DEV, and some that are the OPS. And you may have some that are kind of in the middle, that kind of integration in the middle. And so it's just to have a good, well-rounded mix within the team.
Okay. I guess last questions on my end is how do you get started in Dockers?
The best way to get started is just install it on your local machine. So it's available you can get it on Windows, Linux, or Mac. Now, Docker Desktop, which is the easiest way to get it up and running on your machine. They did change their licensing policy recently. So it does require a purchase if you're going to use it, I think, for commercial use. However, if it's just personal use, you just want on your own time, install Docker Desktop for your personal use. I believe it's 100% free there still. So you can just install on your local machine. It will run a virtual machine on your local machine, your laptop. It will spin that up automatically and run it in the background whenever the Docker Desktop application is running. But then you can just open up your terminal and just start running Docker commands. There's a lot of documentation online. But you definitely get started is on your local machine. DockerCompose, as I mentioned, is very, very helpful when you're doing some testing and learning on your local machine. So I would definitely recommend that.
Very good. Well, I believe we are done with Q&A. I'm not seeing any other questions from the chat. So that said, I guess we'll wrap today up. Everyone will be sending out a recording of this presentation as well as the slides here shortly. And we'll be sending out a survey to let us know how everything went, what we can do better, what you liked, what you didn't like, all that good stuff. Well, until then, we will see everyone next month. Thank you, Jonathan.
Thanks, Mark. Thanks, everyone.